All right, now we're looking at a different travel graph. So Tara rode her bicycle to a friend's place. Here is a travel graph which describes her trip. Okay, so again, we've got distance from home here on the vertical axis, and with travel graphs, you're always going to have distance from home here or distance from the starting point here, and the time along the horizontal axis on the bottom here. So at what time did Tara leave home? So this is the time. When did she leave home? It's right at the start of her trip here, where her distance from home is 0, because she's still at home. She's leaving home. So her distance from home is going to be 0. So that is going to be at 11 a.m. How far did she travel altogether? Okay, so this is her distance from home. And that's increasing until her trip stops, which is here, and she doesn't go any further after this point. So the furthest she gets from home is 40 kilometers. What time does she start her first break? Okay, so we remember from the previous graph that breaks are represented by flat sections in the line, okay? Where you're not moving up or down, your distance from home is not increasing or decreasing. So that means that you can't be moving. If your distance from home isn't getting longer or shorter, that means that you're in one spot and you're not moving at all. So this part here is flat, and that's the first time that it's flat. There's another one up here, but it's asking for her first break. So it's this one here, and she starts that at noon. How long was her first break? Okay, so we know it starts at noon, but when does it finish? Finishes at this marking, but we're not sure what this marking is at this point. So let's look at our next marking over here, 1 p.m. So 2 of these units, 2 units represents from noon to 1 p.m. So that's 1 hour. So 2 units represents 1 hour. So then how much does 1 unit represent? Because she only moved, her break was only 1 unit. So if 2 units is 1 hour, then 1 unit has to be half of that, which is half an hour. So her first break was half an hour long. All right, how long were her rests altogether? All right, so we said that her first rest over here, this first break, was 30 minutes long. But we've got another break over here, so we need to work out how long this break was. So we're going to be looking at the time of the day, and we're going to try and work out how many minutes passed. So when did this break start? Okay, it started here, and that's exactly halfway between 1 and 2 p.m. So it started at 1:30. And when did it finish? It finished about 2.5 grid boxes in. Now 2.5 grid boxes, that's pretty interesting because you can see that 1 unit is made up of 5 grid boxes, yes? 1, 2, 3, 4, 5. So that means that 2.5, well, that's going to be exactly half of 5, isn't it? So it's going to be exactly halfway between this point here, which we said was 1:30, and 2. So halfway between 1:30 and 2, well, what's the time going to be? What's exactly halfway between 1:30 and 2? 1:45. So the break lasted from 1:30 to 1:45. And how many minutes is that? How long was she on this break for? From 1:30 to 1:45, well, it's just 45 minus 30, which is 15. So this break was 15 minutes long. And this break over here was 30 minutes long. So 30 minutes plus 15 will give you the total time for both of her rests, or how long her rests were altogether. So 30 plus 15 is 45. All right, how can you tell when she's traveling the fastest? Okay, so when she's traveling the fastest, her distance from home is increasing quite quickly, yes? Because, she's moving further and further away from home at a very fast rate. So as time goes on, we're looking for a big change in the vertical axis, okay? We're looking for a big change in the vertical direction. So if we're looking at a big change in the vertical direction, but no real change in the way time moves, because time just moves at the same rate, we're looking for a steeper line, okay? So, and you can tell because when we said that she was resting, these flat parts here, well, she's not moving very fast when she's resting, is she? She's not moving at all. So the slowest she can go is going to be this flat line. So it makes sense that the fastest she can go is going to be when the line is really, really steep and the opposite of flat. Okay, so we're looking for the steepest part of the line. That will tell you when she's traveling the fastest. So the answer is the line is steepest. And the part where it's steepest is over here. So clearly at around 2 p.m. or at around 1:45, that's when she started traveling really, really fast.